Hey folks, you're listening to the Java Easily podcast, episode number 13.
Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer.
Hey everybody, welcome back to the podcast. In these three next episodes, we're going to look at the features of an IDE and see just how powerful a tool it is to help us do our jobs. But as always, before we get started, if it turns out that you're completely new to Java and you haven't yet grabbed your Java Beginner's Starter Kit, just go over to our website at javaeasily.com and go grab it there. It's a nice beginner-friendly guide designed to get you up and running with Java as quickly as possible, and it's completely free and should get you up and running with Java programming in no time at all. But anyway, on with the episode. So, since we're going to spend these next episodes talking about the IDE, the first question, I guess, is what exactly is an IDE? So, an IDE, or Integrated Development Environment, which is what that stands for, well, it's kind of like a word processor for code. So just like Microsoft Word gives you a set of tools for producing a document, which is its end product, containing indexes, chapters, footnotes, all that kind of stuff, with features to make that easier. So, for example, spell checking, grammar correction, ability to have pretty layouts, templates, that kind of thing. So just like Microsoft Word, or any word processor in fact, gives you that set of tools to create an awesome document, an IDE does the same thing, but it gives you all the tools you need to make something different at the end product, and that's how to make awesome code. So how does it do this then? Well, there are three broad kind of areas that an IDE gives you. So first of all, overall it makes coding easier, okay? So it gives you a mechanism of being able to structure your projects, and indeed different IDEs will give you different views onto the same project so that you can focus on different types of files that you might want to adjust. So there's this kind of project view aspect. It also gives you syntax highlighting as well. That's where, as you type the various code that constitutes your program, it'll change the look and feel for the different syntax elements that you're using in the code. So typically this means that keywords, for example, those are words that are used by the language, reserved by the language, as part of its core programming syntax. Those so-called keywords would end up being bold. Things like for, do, continue. It also change the formatting of the types that you use. It might change the formatting of whether a method's static or not, by placing a static method in italics, perhaps, like in IntelliJ IDEA. And it'll usually as well even decorate the code that you're looking at with extra things that perhaps you don't see initially. So for example, if you override a method in a class, there's usually a symbol to be able to jump back up to the method that you're implementing in the interface or in a superclass. It gives you as well a way of being able to collapse and expand different code sections, all that kind of good stuff. So the first aspect that you see when you're going into an IDE and using it for the first time, the most immediate stuff is syntax highlighting, but there's also all these other kind of extras that it gives you to be able to visualize your code that bit better. Okay, so you're coding along, you're in the IDE, and just like Microsoft Word does, when you make a mistake in spelling or some kind of grammatical error, you have the kind of squiggly red underline or the blue underline. Similarly, an IDE does the same thing for you as well. And it'll actually give you corrections, suggestions as to how you can actually fix the piece of code that you've written. So it gives you that extra level of help along the way. Now, in addition to just spotting the issues that you have with your code and suggesting corrections, it can also take this a step further as well. It can even take care of boilerplate code for you. So boilerplate code is code that you kind of have to churn out with no thought behind it. It's code that can be very easily auto-generated by the IDE itself, but it's somehow code that's required by either the framework that you're using or Java conventions itself. And it can be a bit of a chore to write. So for example, the classic one here would be when you're writing a POJO. That's a plain old Java object. So maybe you're writing a POJO, and a POJO basically is something that enables you to just capture data points for an object without having any behavior attached to it. So normally, in object-oriented engineering, we have this notion of the data that is inside an object, and we also have alongside that, we have the behavior of the object too. So in other words, the methods that we expose to the user of our class, which allow the user of the class to somehow manipulate the data inside that object. So even though that's a core tenet of object-oriented engineering, with POJOs, we don't have that at all. With POJOs, they're basically just kind of dumb data-holding objects, if you like. And these can be used for DTOs, for example, or data transfer objects. That's when maybe, for example, you're wanting to ship back a response to a HTTP request back out to the front end, and you just need to have kind of a data holder for those set of data points that you want to ship back to the client without having to have any extra behavior attached to that object. So with these POJOs, typically you have to write getter and setter methods. So suppose you have a simple POJO with a name and an age, so a string name, an int age, representing a person perhaps. Then as part of that POJO, you'd have some extra methods on there. You'd have a method to get the age and set the age. So to get the age, you're going to return back an int, which is the age that's inside the object. And you'd also have a matching set age method as well, which would take an int, which is the new age that you want to store down on the object. So you'd have getters and setters for the age, like we've just said, and for the name as well. So that's basically 4 methods you don't really have to write, or you shouldn't have to write, because they're so trivial and so easy to write. They're always the same pattern, they're always the same style, and you can imagine that churning out these methods can become pretty tedious. And so therefore, another thing that an IDE will give you is the ability to auto-generate these methods. And it's not only methods such as getters and setters, there's more advanced things as well that an IDE can do. Like, for example, generating constructors or allowing you to override methods, and it'll automatically complete that or write out that method signature for you, giving you kind of like a blank method where you can put your code in there that you're going to override. There's also code generation as well. For example, if you invoke a method which is going to throw an exception, the IDE will give you the opportunity to say, do you want to wrap this in a try and a catch? And then it will write the try and the catch structure around that method, such that the method call itself is in the try block, and then there's a catch block afterwards, which the IDE is also written for you, where it's pre-populated the exception type as well that's going to be thrown out of that method. And that's useful. Or alternatively, it can even give you the ability to say, do you know what, you don't have to surround this method with a try catch. Instead, you can just add a throws clause to the method which includes that method invocation, and all that kind of good stuff. An IDE really, for me, the good point about an IDE from the coding point of view is the fact that it doesn't get in your way. If anything, it enhances your ability to code and the agility to do it. In other words, the speed within which that you can knock out code very, very quickly. And when you get to a level where you're really, really good with an IDE, you start to find that you are focusing more on the problem itself and not really kind of thinking about the code you're going to write. You're more thinking at the level of the problem as opposed to at the level of the code. And I guess that's the same as something like Microsoft Word or whatever, where you're focusing on the text that you're writing and the ideas that you're putting in your stories or blog posts or whatever, as opposed to actually thinking about the mechanics of, okay, how am I going to format this, and how am I going to put a paragraph here and that kind of thing. So code generation is a big part of it as well. And now going even more advanced, so these things we've given here have been pretty much going from basic to advanced. So project structuring, then we've got the syntax highlighting, correction suggestions, that kind of stuff, the generation of boilerplate code and code generation in general. As we're getting more advanced with these functions in an IDE, possibly the most advanced one is refactoring. And that's really a way of being able to start to redistribute your code or reshape your code or kind of change the code around in such a way that ultimately it makes it tidier and a better design. We can't really get into refactoring here. We'll probably do an episode on this at some point in the future. It's a pretty advanced concept, but refactoring, very powerful tool, can enable you to do some really good stuff in terms of moving around the code and kind of reshaping it or remolding it exactly how you want it to be, with a minimum amount of kind of, I guess I would say, like debris left around. This might be functions such as, for example, extracting a method. So suppose you've written a chunk of code, say it's like 15 lines long, and you think that 5 of those lines, maybe it's inside a loop, for example, 5 of those lines really could be extracted out into their own method, so grouped together into their own method to make the code more readable, because then the person who's looking at that code, trying to comprehend what's going on with that loop itself, can then concentrate more on what's happening with the loop and the things around the loop, as opposed to getting lost in the weeds of what's happening in those 5 lines. So maybe you might do a refactoring called extract method, which takes those 5 lines of code and pushes them into a new method. So the IDE then will create the method for you. It'll give you a pop-up, say what you want to call the method. You type in whatever you want to call it, and it'll then write that method for you with any arguments or parameters it needs to take along from the context of the code that's surrounding those 5 lines. And you can again adjust the names of those parameters. And then that way now in your loop, you just have this one single method call in place of the 5 lines of code you had before. And in doing that, pretty trivial refactoring, but in doing that, you've made the code much easier to comprehend for the next programmer who comes along and has to understand what's happening inside that method. So the first point about IDEs, in general, the big high-level kind of headline here is it makes coding easier. That is, your ability to actually type your code in, shape it to as you want it to be, spot issues along the way, all that good stuff. The IDE's first primary function is to get you doing that as easy as possible. Now in the next episode, we're going to look at how the IDE improves the developer experience and makes your lives so much more easier than if you had to do a lot of the heavy lifting yourselves. But as for now, all that remains to say is have a great day, keep going with your Java journey, and I'll see you in the next episode.